Hello and welcome to this afternoon's webinar. A fantastic topic this afternoon. Music is maths with feeling. I'm really excited about this one. Sanjeev, I would pick as probably one of our most accomplished programmers. He's really impressed me again in sessions that I've attended of his, showing me things that I can do with TI Basic. Now that there's the second programming language on the TI calculators, Python, Sanjeev is running with that as well, and he's an expert on programming in both of those languages. You can see on the blurb there that he's head of maths, very keen on STEM, STEM coordinator at Furbank Grammar School, range of positions that Sanjeev has held there, and has also been actively involved in piloting a lot of our STEM projects. In the background, you've got me as host. My name's Brian Lannon. There's a little bit about me there. Sanjeev, we have some wonderful ideas to hear from you as we see your screen. And thank you, Sanjeev.
Hi, everyone. So my section is titled Sounds of Music. So this is the title I gave to my segment for this webinar. And the maths component that we are exploring is really indices and exponential equations. And when I say exponential equations, it's a geometric sequence, and we'll be observing a recursion pattern on our CAS calculator, which is the TI-Nspire. So I'll be talking more in terms of a piano, but whatever I'm saying for a piano will hold for a guitar or any musical instrument. So the question is, when you press any key on the piano, what note are you playing? And I've got over here the guitar and the piano keyboard. And you can see I've got all these letters A, B, C, and so on. And then there are white keys, black keys. So when you strum a guitar or you play a key on the piano, what note are you playing when you press a key? And at the moment, on my screen, you'll see I've just highlighted one particular key in red, and we call that as the middle C. Most musicians want to tune their instruments and everything with the middle C. Now, I'm going by a 88 key piano, but you can have keyboards which have 59 keys or 67 keys. But we'll just, for today's session, use the 88 key piano. So just to mention, every musical instrument produces a sound as a result of some vibration. Now it could be a vibration of an air column, and that would be wind instruments or brass instruments. It could be a vibration of strings, as is the case in piano or guitars, or it could be just the vibration of a diaphragm or a metal plate, so the drums or the cymbals. So the musical instruments actually are classified into three basic categories based on the type of vibration that happens. Now, we often use the words frequency, and I just noticed the C is missing in frequency. I can correct that, the pitch and the note. So all musical instruments, they produce a vibration of a certain frequency, depending what frequency you have played. Now, musicians refer to the frequencies as pitch. And again, coming on to the notes, notes also are frequency dependent, but on a piano, you could have several notes for which I would say A. And on a 88 key piano, I would have 8 A notes. So the first one would be referred to as A1, then the next would be A2, and so on. So there is a pattern from one note to the other note. When I say one note to the other note, from A1 to A2. So we're going to explore that pattern. But before that, most of you may be familiar that frequency is measured in the terms of number of cycles and number of vibrations per second. And the unit is named after a physicist, Hertz. And the symbol is just the capital H and Z. So cycles per second is written as Hertz. So if I'm playing a note of 440 Hertz, it's 440 vibrations per second. So I've just gone by the A note over here, and you will see I've got a table there, and the A notes on my screen are displayed by yellow, and then I've just colored. The green notes or the green key color is for the C note. So we'll talk more of the A notes at the moment. So the first key, which is 1A, has a frequency of 27.5. And how do we get to that 27.5? Actually, it's key number 49, which is 440. That's the principal key. But we'll start with the first key. So if you look at 1A, the frequency is 27.5. Then if you look at the next A note, which we refer to as A2 or 2A, it's 55. And what's the pattern you will observe? From 27.5 to 55, you're doubling it. Then 55 to 110, you are again doubling the frequency, and then 110 to 220. So basically for the A notes, if you start from the very first key, every time you go to the subsequent A note, you are doubling the frequency. Now same holds for the C notes or B or any notes that we are playing. The frequency actually doubles each time. So from one C note to the other C note, the frequency would double. So I've just shown right at the bottom of the screen, you will see I've got all the 8 A notes numbered or titled A1, A2, A3, and up to A8. So the pattern is they are just doubling. And I've got this table which shows you 3 different ways in which you could do the recursion. So same can happen on a guitar. So what I've got on the screen is the 6 strings of the guitar, and there are 12 frets, and there are 7 A notes. So the second string has got 2 A notes, and all of them have 1. But I could have a guitar with 24 frets as well. And this is the 24 frets guitar, and you'll see there are 13 A notes. So all the strings have 2 A notes, but the second string has got 3. And it's because of the pattern it follows that there are 3 in the second one. But it follows a logical pattern. Okay, so how do we get the A notes on the TI-Nspire? We will look at a recursion pattern. So I've got my calculator screen on, and I'm going to actually create a list. And list goes in curly braces or brackets. So I'm going to enter the first key over there. One is for the key, and I'm entering the starting frequency, which is 27.5. Now, when I click enter, it displays 2 answers, answer 1 and answer 2. So I'm going to add 1 to answer 1. So sorry, I'll just go back and correct that. So that should be my answer 1. I shouldn't have the negative. Yeah. And answer, and then I put the reference, which goes in square brackets. So the answer 1, and I'm going to add 1 to this. And then I'm going to now pick up answer 2, which is 27.5, but I'll just go as answer 2 because I'm setting up a recursion pattern and answer 2, and I'm going to multiply this by 2. And this will set up a recursion pattern for me. So when I click enter, it gives me 2 and 55. Now, if I keep clicking enter, it gives me all the notes. So I'll go up to 8, and that's what we have. So this is doing it on the CAS, just by doing a recursion pattern. Now I'm going to do the same thing, and this time I'll go by key numbers. So the first key, the 13th key, and 25th key. So the A key repeats after 12. So I'm going to do exactly the same thing there and run this for you now. So 1 and then 27.5. But this time to the answer, first answer, I'm going to add 12 because it's 12 keys that separate the A note. And this time it's going to give me a display by key number. And sorry, I'll just do that again.
That's a really clever way of doing it, I reckon, Sanjeev. I like that. Yeah. And of course, you get the repetition.
Yeah. So I'm going to do plus 12. That's to the, and the second one, no change. We'll just go the second answer multiplied by 2. And just do that 8 times. So 25th key, 37th key, 49th key, 61st key, 73rd, and then the last one, the 85th key. So that's just doing all the keys there. So now we'll look at doing it on the list and spreadsheet application. The same thing on the CAS. So I'm going to add in column 1 or column A, and I'm going to just call it key 1 and 2, 13. And I'm going to just fill this up. So use the fill command and keep going down. And I'll go up to number 8 because that's where I need to go. So this is giving me the key number. And over here, I'm going to enter the note value. And here I'm entering the formula. Now you can see the formula at the bottom of the screen. So I'm going 27.5 times 1.0 and 59. And I'll ask you a question and I'll give you an explanation. Where did I get that strange looking number from? To the power of key. And it just populates my column there. So that's how I can do this on the list and spreadsheet page. And I'll explain that strange number 1.05946, whatever. How did I get that number? So we'll come to this right at the end of the screen, but I've written as 2 to the power of 1 over 12, which gives me this number 1.05946. And the explanation, as I said, will be towards the end of this presentation. Okay. So moving further from here, I'm going to just do a graph of this. So if I go and add a data and statistics page and I add key on the x-axis and the note value on the y-axis, and now I can do a regression and an exponential regression. And if I drag this, you can see it gives me 27.5, which was my starting frequency, and that 1.05946. The value that we had. So this is just observing this as a curve. So that's an exponential curve, and this is a good way to introduce exponential equations to curves. So you can start with base 2 and go 2 to the power of 1, 2 to the power of 2, and then of course we can move on to this particular pattern over here for musical notes. We'll look at doing this as a sequence. So I'll go into the control M, I'm on the notes page, and then I'm going into the catalog to get the sequence command. The first thing I'm going to do is to generate the key numbers. So I've gone 12 times X because the A note appear after 12 keys, and I've done +1, and it gives me all the key numbers over here. And now I'm going to do the note frequency. So it's 27.5 times 2 to the power of X, and then again I'll go X, 0, 7, and that should give me all the frequencies. So I've just shown you how we could do it in a few different ways. So recursion, we can do it in the list and spreadsheet page, and now I've done the sequence command, and towards the end I'll show you how I could do this in TI Basic and also in Python. So if I want it as an exact value, when I'm on the notes page, it gives me the option to do that. So I'll just show you when I'm in the evaluate section. If I do evaluate, it goes into the exact form. And if I go back and so approximate and evaluate, there are two options. So evaluate selection goes in the exact form. So that's how you could do this using a sequence command. Okay, this same thing can be obviously done with the C. We did it with the A note. I could do it with the C note. The only thing I have to keep in mind that the first C key is key number 3 on a 88 key piano. So the second key will be 12 keys later, so which would be 3 plus 12, that gives me 15. And the starting frequency would be 32.7. And I'll show you how we can generate that number 32.7 later on. And I've run the sequence command and you could see all the frequencies. And the last key on the 88 key piano is actually the C, and that has a frequency of 4185.6. So that's well within the human audible range. The human audible range is 20 hertz to 20,000 hertz, and as we get older, that frequency reduces. So 4,000 is well within everybody's range to hear that particular frequency sound. So moving on to octaves. Now there are 12 keys between any octave, the first octave, second octave, and there are 8 notes. That's why we call it an octave. And in an octave, there are white keys and black keys. There are 5 black keys and there are 7 white keys, which add up to give you the 12 keys. Now, the black keys have a note reference as well, and my next screen will demonstrate that. So if you look at this, I've got it's right next to the, if you look at my left hand bottom screen, it says it's got a C on the left, the white key, and then the black key is called a C sharp. So there's a sharp sign over there. But I can also call that key number 2, which is C sharp, as D flat, because D is on the right. So that key number 2 actually can be called a C sharp key or a D flat key. Likewise, if you look at this on the right, I've got a G on the left, so it's called a G sharp, and I've got A on the right of the black key, so it's called an A flat. So G sharp and A flat will actually be the same frequency. So that's just explaining the octave. So I've shown you octaves over there, and I'm also showing the middle C. Now octaves can start for a musician from anywhere, but they prefer starting with C. So it should go from C to B. So and then next C to B. So that would be an octave. So you've got several octaves on a guitar or a piano. So now we want to model all the 88 keys together. So the first key we said has a frequency of 27.5, and we refer to that as A1. And then the 13th key has a frequency of double of A1, which is 55. And we just mentioned there are 7 white keys and 5 black keys in an octave. Altogether, there are 12 keys. So if I want to find the frequency of each of the keys in the octave, this is what would happen. If I look at key number 2, it would be 27.5. Now, instead of doubling, we are going into 2 to the power of 1 over 12 for the next key. And then if you look for key number 3, it's 2 over 12. So we are dividing it by 12 because there are 12 keys. And then, of course, you've got 1, 2, 3, and so on for those key numbers. So if you notice, if it's key number 4, it's 4 minus 1, which is 3 is my numerator for the fraction part of the power. So the fraction part of the power is always 1 less than the key number. And when I say it's 1 less, it's the numerator that I'm referring to. So if I go to the very last key, which is 88, the frequency for the 88th key would be 27.5 into 2. And the power is 87, which is 88 minus 1 divided by 12. And from here, I can actually write a general rule. And right at the bottom of the screen, you will see for nth key, which could be any number, it's going to be 27.5 into 2. And the power is n minus 1 divided by 12. So that divided by 12 is because there are 12 keys in an octave. So we can find the frequency using this rule for any given key. Now, most pianos, or rather the keyboards, may not be 88. So they don't want to start with the first key. Instead, most of them actually start with the key A4, which has a frequency of 440. So this is actually a mathematically transformed equation. And we are starting with key number 49, which is 440. So this is a general way, because some keyboards can only have 59 keys. There are others with 67. And that is why we start with a frequency of 440 and then do a horizontal translation in the equation. or translation in the X direction. And this basically would give you still the same values. So as I said, I could write a code in BASIC. So here is my code in BASIC. It's a very short code that I've written over here. And I don't want to go too much into the details, but I'll just explain you. For actually is equivalent of a loop in TI BASIC. So it's basically setting up the recursion pattern. It goes to the first key, second key, third key. So for I, so I would start with 1. Then in the next loop, it would go to 2. And it's basically substituting that value in this formula over here. So, and I've written 55 over 2 for 27.5 just to be in the exact form. And I've rounded up the values to 2 decimal places. And then, of course, I'm saying display. So display would be the information that I would see on the screen. So it's going to do the key number and it's going to give me the frequency. So let's run this program. And now when I run this program, it's just Control R for running the program. And this is the output. You'll see key number 1, frequency, and so on. And it gives you the frequency for all of them. And that's a quick way of obtaining the frequencies using the TI BASIC. Now, one of the things that I was hoping to do today was to connect my TI Innovator Hub, which directly connects to your computer or to your calculator. And the TI Innovator Hub actually has a chip inside it, and then you have a sound card as a part of it, and you can actually play any note over there. And I've actually played all the notes in one of the files, and it starts from the lowest frequency from A, and it goes to the 88th key. So it's playing all of them, and I've just given a pause of 0.25 seconds, so you can distinctly hear all of those frequencies. So unfortunately, I can't play that sound file because of the lockdown. TI Innovator Hub that I have is actually in the school. So I can't really do that. But I've done exactly the same thing now on Python. And you will see it's a very simple code that I've gone in Python. So it's just got 4 lines really. So the first one is the key number. And it's an empty list that I've created, and a frequency, it's got an empty list. And then when I run the loop, the for command, you can see the same formula over there. I've got 55 divided by 2. You could write 27.5 there, and it will do exactly the same thing. So this is just the entire code, and it's just 4 lines over here that you see. And now if I run this program here, you will see it generates all the output. So Control R, and you can see all the key numbers and then the corresponding frequencies. So this is in Python. And both Python and TI BASIC, in my opinion, you run or basically do some coding 3 or 4 times. Now, if you go to the TI website, you've got 10 minutes of coding. If you learn that, you will be good enough to pick up coding. It's not as difficult. As you see, it's just basically 4 or 5 lines that we are talking about of code to do these simple things. And let's okay, I'm just going to do a graph over here finally. It's the same program, but I've just got these few extra lines, and I'm going to run this as a graph. So it will plot a graph for us over here. So this is again in Python. We've just done a quick graph for that. So I'm going to stop there. That's really it from me. And if there are any questions, I'm happy to take those questions and answer your questions here.
Thanks, Sanjeev. Yeah, that's great. And attendees, now's the time to type in to the question box. Remember to direct them to both all presenters, all panelists. Now I'm going to, normally I would switch back to myself for the closeout here, but Neil has just in the background made the offer to actually play some notes for us here. So I'm going to thank Sanjeev and swap back to Neil.
Can I just do one more thing quickly? It's just something that I thought I'll show you.
Yep.
Are you seeing my screen still?
No, I just swapped it across. But it's back to you if you want to do a share screen.
Yeah, just something I was doing with my students the other day, and this is in Python. So if you're seeing my screen now, are you seeing it?
Yes, we have the
Yeah.
Python there.
So what I did with them, I said they have to correct this. So I've actually simulated a keyboard from them for them, and it's put all the white keys. And I said I'm going to put the black keys in correctly, and they have to correct it. And the students actually were able to modify my code and generate this. So this is all in Python. So the students enjoyed this. So they placed the black keys correctly. So as you know, it goes 2, 3, 2, 3. So they were able to modify this correctly. So I thought I'll just show you this. So it's a nice task as well.
Right. That's yeah. There's just so much in this, and we could run a whole course on this topic. I reckon. For me, it aligns a lot of wonderful planets here. You've got the maths, you've got the physics, you've got the coding, and of course the music, which is something that can be used as a motivator for students and an area of interest that they already have that we can tap into. So that this is a real winner. Thank you again, Sanjeev. And you're the one I look to for coding on these things. You've got some great ideas there. That brings us to the end of today's session. So once again, thank you to all our attendees. Thank you to our panelists, and good evening to all.